we have here a standard forces question. But before we get into this, I guess I kind of want to explain what this channel is all about. I guess you can tell from it, the title, that I'm just one of your regular college physics students. I wouldn't say I'm the most reputable source, and I suggest you ask your physics teacher about any questions you have. But I understand that there are some times where you procrastinated, as I have a lot of times, and you just have that one physics question left, and you just need to quickly finish it, but you don't know how to do it. So I guess I'm here for those kinds of situations. Maybe I'll do some more in the future, but we're starting with this one for now. So we see that this is one of Atwood's forms. We see it here that mass A is 14 kilograms on a smooth horizontal surface. So this means that there is no force of friction acting in this direction. So we can leave that out of the free body diagrams. And it's connected by a thin cord that passes over a pulley to a second block with the mass B equals 6.0 kilograms, which hangs vertically. So before we start, I guess the first thing you have to do is draw some free body diagrams for both MB and MA. So let's start with MB. See that there's tension pulling up here, and there is a force of gravity, which we should know is equal to the mass times gravity. And for block A, we see that there's tension in this direction, but like we said before, there is no force acting in this direction. If there was, this would be the friction, as if the block was moving this way, friction would act past this way. But since we don't have any friction, we don't have to worry about that. And so we see from this free body diagram that I guess we can assume that this is going downwards and this block is going to that direction. So, and then we have to find our formulas. So we know that F equals MA, and of a B in particular here. And so using this free body diagram, we can see that MB of A is equal to mg, if we're considering that this force going down is winning, minus the force in the opposite direction, so this is negative. And then we find the equation for this part, which is ma of A equals to just tension. So if we're adding these two equations together, and since we're solving for acceleration, I guess I should have said that first, we're solving for acceleration in the system. So we can add these two equations together, which these two cancel out. So we're left with MBA plus MAA equals MBG. And we can take out MA here using the distributive property. MB plus MA is equal to MB times G. And since we're given the masses here and here, we can just plug those in for the masses to 14 plus 6 equals 6 times 9.8, which is gravity. Just get our calculators out. See that this is 58.8 times 20. So we divide this by 20, and then we get the acceleration from that, which is 2.94 meters per second squared. All right, so that's the acceleration. Now, there's another question that asks us to find the time that it takes MA to travel a certain distance. Let's say the question says MA has to travel 1.25 meters, and it's asking you find the time that it takes to travel this distance. Well, since we just found a, we can use one of our kinematics equations, which is the delta x equation. So v initial t plus 1/2 at. And so we know that it's starting from rest and it starts moving. So v initial would equal to 0. So this is just completely out. It's 2.50 equals 1.25. 1/2 of the acceleration we found. Sorry, it's getting a little bit crowded. Then we can solve for t. It's the square roots of 0.85, which we find to see that it is 0.922 seconds. It's the time. So this is the time that it takes block A to travel this distance. And so there's a third part to this question, well, for me at least there was, and it was asking if, hold on a sec. So it says if mb is equal to 1.0 kilograms, how big does m of a have to be if the acceleration is to stay at g over 100? I believe we can just use this equation that we found earlier. And that seems to work. So acceleration is 9.8 divided by 100 is 0.098. It's going to be a little cramped. Just so 0.098. Maybe I should have used a different color. Oh well. Times mb. Actually, let's not use this one. Oh, let's use the actually, yeah. It's mb a plus maa equals mbg. So it tells us that mb is equal to 1.0 kilograms. That's 1.0 kilograms times the acceleration, which is 0.098, plus m of a equals 1.0 times 9.8. Find that 0.098 plus m of 0.098 equals 9.8. So we subtract this value from this value, which isn't gonna change it a lot, but you have to do it. So, and that m of a times 0.098 equals 9.702. So we divide this by 0.098. Then we find m of a to be 99 kilograms. So this is the weight that m of a has to be to keep the acceleration at g over 100. I mean, this definitely doesn't look that professional, but it's what you're going to have to get used to. A lot of formula solving. So I guess that's it for this question. If you have any questions for this specific problem, if you have any questions, leave them in the comments, I guess, or ask your physics teacher. That'll be the better choice. Right.